Hello, if in doubt, sorry about that. If in doubt, go back to my mobile. It took me ages to set up this whole new configuration. Have a look at it. I've got my visualizer, and I've got the lovely mess behind, and I've got my whiteboard all ready to go. And then when I was doing my best to work out how to show you the next activity, I managed to stop the Zoom. Sorry about that. So here we go. We're continuing with this, and I'll show you as best I can without the visualizer. Say bye-bye visualizer, bye-bye, see you later. It's a matter of just working it out. Microphone's not going to work, to get rid of the microphone. I'm getting there, but it's a slow process. Some people are really fast at these things, and I'm not. And I'm actually showing you that it's all right to not be the best at everything and the quickest at everything. You can still get it done. You can still do a good job. You can still make activities and lives for people who, I'm making lives for people to help people all over the world do maths in a rewarding, engaging and interesting way, so that they can learn to love maths. Or if you already love maths, it's giving you activities that are interesting, which is very important to maintain that love and the beauty of it. So what we're going to do is get some newspaper. So we need newspaper, we need rulers, and this doesn't like this very much because, right, okay, how's that? Can you see? You see my lovely mess? I've got all my odds and ends over there. Fine. So what we're going to do is we're going to make, we're going to cut a newspaper. Now we're going to cut it nice and carefully. So that is, maybe I'll use scissors. I'll put my scissors away. Tidily, I didn't get them out this morning. Okay. We want this to be an absolute definite right angle. So this needs to be cut nice and carefully, because that wants to be a nice right angle. The right angles are super important for this activity. There's slightly different, well, we can still do this for early years actually. We're going to be doing the early years session. That's not the bestest right angle in the world now, is it? Okay, so I'm going to now fold this over and improve that line. Get rid of that. Improve that line, because we really do want this to be a good right angle. Critical, absolutely critical that we have a good right angle here. So following that line, I'm going to draw it, and then I'm going to cut along the pencil mark to make sure we've got a very nice right angle. So it's a bit jaggedy. I've cut it in a bit of a jaggedy way, and it wants to be a nice straight line. If you've got a guillotine, even better, but most people don't have a guillotine just sitting at home. So, but a pair of scissors, just cut nice and carefully. Concentrate. Doesn't matter about the bit in the middle so much. What matters is that right angle on the vertex. Okay, good. Now I'm going to cut this piece of paper into 4. This is not critical. In fact, you want it a bit rough so you know which is the bit that isn't the bit you want. Now I'm going to cut this one into 4. These two into 4. Halving, nice. I like this. Halving or doubling the amount of paper, halving the area. Right, now I'm going to match that right angle to that right angle to that right angle to, where's the right angle? Let's get it right. Let's get the right angle right, yeah? Oh, never mind, that's my joke. Okay. Now, super important that these 4 right angles are exactly lined up. Do they look lined up there? Not very much. So we're going to work on that a bit more. We could get our paper clips out. Still Still not. Keep going. It's really, really important that those... have I got it? That's pretty close now. That is pretty jolly close. I think it's close enough. In fact, I don't really know. That's not lined up there. Okay, right. Now, any triangle, you can go crazy. I'm going to do a really quite sharp triangle, as in a kind of a sharp wedge. This has got to be a straight line, actually. Thinking about it, I'm going to draw this. It has to be a straight line. I can't ad-lib it. I'm going to draw a straight line here. It's called the hypotenuse. If you can say, can you say Tyrannosaurus Rex? I knew you could. You can say hypotenuse. Now it's really important to hold this and not let the bits of paper slip. You could definitely use a paper clip here. Okay, get this line straight, and here we go. Follow that line along. Make sure they're all lined up. You can make any triangle you want. You be different. Do something different to me. And then send us in pictures of what you've done. Now that didn't quite make it, that last one. Somehow I missed it. I'm just going to trim that. Okay, now, so I'm going to leave that for some other crafty job that I want to do later. And here we have 4 congruent triangles, so they're all the same. Now, the task is to, let me get the wording right. I find it when I ad-lib, things go wrong, and then I make brilliant mistakes and fantastic failures. Hello, Alok. And, right. So, what we want to do is we're going to make a square. This is where we want some normal paper. I'm going to get my recycled paper here. We now have I'm going to draw a frame. The frame I'm going to draw is, I'm going to call this, if we call this A, doesn't matter which is A or which is B. I'm going to call this one A and this one B. This one does matter. This one is C. That one always wants to be C. And that way we're all singing from the same songbook. We're singing the same song with the same rhythm. And so what we're going to do is we're going to make a square. Oh, is this going to be, oh, this isn't going to be big enough. Is it? Oh no, this isn't going to be big enough. So this piece of paper, I have found a flaw in my creative triangle, because actually I'm going to redo that. I'm going to recut that. See, I am showing you all the different problems that could happen. Now, I really do need that paper clip. Go get a paper clip. Doobie doobie doo, gives you time to get caught up. Go and get a paper clip. So, this is just a practical matter. If you make your edges A plus B less than the width of a piece of paper, whether it's A4 or the American size, then you'll be able to use that easily to make a platform to build this on. Now, so I'm going to now just put, I don't want to start all over again. I think it'll take less time if I do it this way. These paper clips aren't very good. Never mind. I think I've bent them too many times. So now I'm going to make sure they're lined up. That edge is lined up. And that, not really doing much. Here we go, let's see if I go this way. That edge is lined up. That might be enough. Make sure they're nice and straight. That edge is lined up. It's not going to be the most perfect one you've ever seen, unfortunately. But, oh, here you go, put one there. There you are. Now, that wants to be less than that, so we're going to go up to about there. I'm going to draw it. I'm going to draw it, go up to there. Ruler. Get my scissors. It's for practicality. If you've got a bigger piece of paper or a bigger platform to work on, I just want to demonstrate it to you in a way that you can actually do it with a piece of normal paper. These are scrap paper. This has all been reused. It's all reusing the resources on our planet. Never have single use if possible. Ah! This table is curved. That's something I've discovered about this table. It's got curvature. So when I use it to draw, and I've actually got a dip in the middle there. Right, here we go. Follow that line. And now, hey, this is escaping. Cutting all four together, you might need to do it in pairs, 2 people doing that together, because it really is actually not cutting very well at all. Okay, whoa, now I've ripped a whole piece off my triangle. So take a little bit more care than me. So what you want to do is you want to make a square that is A plus B. That's the length of it. That's how you know how long it's going to be. So the square is going to end just about there. Now to make a square of that length, we can draw a line along here. That's pretty easy to follow. Make sure it's parallel to the edge of the paper. And then to make the full square, all we have to do is fold this over, and then we know that that's a square, so we can cut along here. And cut down here. Now, in theory, we should all have a different size square at this point, because we've all cut out make it that way so it sits flat. We've all cut out a different triangle. So now what we've got to do is find a way of fitting these on. So this is a puzzle that you might have solved earlier. And what we're looking for is we're looking for another square. So this is a puzzle you would have solved over the weekend. And we're looking for another square. And this will be our set area, our set square. It's not a set square, but it is a set square. It's a square that's going to help us find out more about right-angled triangles. So put them all on. Now they've got to be in their congruent form. You can't turn them over and see if that will, as a mirror image. They all have to be, so you have to take them from there and simply rotate and transform them. Only rotation. No, you don't want to fold them over. Keep them that way up. Start with them all the same way around. Keep them that way up. And just rotate them round until they are. And if you notice, you might notice by what angle you have to rotate them as well to get to the different vertices of the square. So we're now looking at this. So I've got this. I'll make sure that I am leading you right. So if we join, so we started with A and B, there we have A, and I tore A off, silly me, and then we had this length here that was C that we had to modify because I couldn't easily make a square. Now I could have actually done that with some newspaper, but newspaper isn't, hi Eddie, a newspaper isn't that easy to obtain. So, I mean, it's not so easy to see. This is a nice clear blank space that's easy to see. Or you could paint your newspaper. You could do that. Just have another piece of newspaper or card. Could have used a piece of card. That's also true. That would have been fine. And cut it to this size, or drawn a shape on it. That's another possibility. I could have just drawn a square on it. But I like the idea of doing this. So we can now look at the areas. So the area, if you take two, now this time I am turning it round because this takes up the same amount of area. It would take the same amount of paint as it would whichever way round it is. So now for doing this, it's okay to turn it upside down so that you can see that I've got a rectangle of length B, that's B as well, and edge length A and B, and if you put them together you have a rectangle, and the rectangle area of the rectangle is A times B. So the area of half the rectangle, we know it's half because we made them deliberately to be exactly the same size. So if the area of the rectangle is A times B, the area of half of the rectangle, which is one of the triangles, is half A times B. That's it. Now I could write that on here. I'm just going to write this up. So we have, are we going to be able to see this? I had it all set up for my beautiful visualizer, and then I stopped the live. I went plomp and stopped it. So we've got a rectangle made up of two triangles that are lengths A and B. So the area of the rectangle is A times B, and then the area of one of those triangles is half of that, because those two are identical, half of A times B. There you go. That's how that works. Now, next, what are we doing next? So from looking back at this, back down here, I thought it was all so beautifully organised, and then by messing it up, I've messed it up. So now, back on here, be careful what buttons you press, that's what I say. That's my magnificent learning from my magnificent mistake. Be careful what buttons I press. Make sure I press the right button. Doing things live is quite challenging, let me tell you. So now, the area of each of these triangles is half of A times B. That's half of A times B, that's half of A times B, that's half of A times B, and that's half of A times B. Half of the area of the rectangle that we made by putting two together. All right, what is the area of this square in the middle? Well, they're identical triangles, they're congruent. We made them all together. So the length of every single of the diagonal edges called a hypotenuse. It just is called a hypotenuse. Again, can you say Tyrannosaurus Rex? Hi, Jan. Can you say Tyrannosaurus Rex? In that case, now say hypotenuse. Hypotenuse. Right. Now, the area, we've worked out the area of the four triangles, which is half of the area of the rectangle. Let's just do that again. It's half of the area of the rectangle, and the rectangle is A times B, that's the area. Now, the area of the square in the middle is, that's a C, that's a C, that's a C, that's a C, they're all the same, so it's C times C. So the square, and we can see it's a square because all the edge lengths are the same. What we don't know for a fact yet is that it's an actual, I'm not sure about whether or not these are right angles, but we're not going to worry about that for a moment. We're just going to call that c squared. So it's c times c. In fact, I'll even write that down. C times, c, which equals c squared. So that's c squared, and this whole big outer square is a total of c squared plus, let me see, 1, 2, 3, 4. 4 times half of a times b. So it's c squared. So the big triangle, the big square, all the big square that we got. So that's what we've got. C squared, and so it's this square plus the area of that, plus the area of that, plus the area of that, plus the area of that. So it's 4 times, and then we worked out that each one of these is half the area of the rectangle if we have 2. So each one of those is half of a times b. Right, so that is the area of the big square. Right. Now, another position we can put it in is, I'm just going to cover that up so that it doesn't distract us. That's the wrong colour. I'm just going to, we don't want to have that there. We're going to put that there. There you go. Right, now, we're now going to do it slightly differently. We're going to make the same, use the same area. Make sure we've got the right angles in the right place. There's your right angle. So now we've got the same area. So the first one was, the big square was, if I put this up here, it was, oh, what's this? This is permanent. Oh, that would be a bad thing. It was c squared. So we had the big triangle. Let's see if I can get this right. Boing. Oh, dear, 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 dear. Boing. Boing. Oh, dear, 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 dear. That's the wrong way around. That goes all the way. Boing. Boing. No, I'm not getting this, am I? Let's get this right. Start again. The big square. The big square was boing. That's not it. I know what I'm doing wrong, silly me. There we go. That's it. Boing, 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 and boing. So that was c squared in the middle, and these were all half of a times b. That was a, that was b. So it was the whole thing was c squared plus 1, 2, 3, 4, 4 times half of a times b. Now the next one we're doing is, let's make sure I get this right, it's the same size, and we've got so this is B, this is A, this is A, this is C. No, it's not. I lied. This is B. Okay, because B's along there. So the same big square that we've got, let's see what we've got. That square would be B squared, and that square there would be A squared. And the area of both of these rectangles that we've made is A times B. So that means that the same area as that, the same big triangle, is made up of A squared plus B, that plus that, plus B squared, plus, now we've got, each one of these is A times B, so it's 2 A times B, because there's 2 rectangles, one there and one there. Oh, can you actually see what I'm doing? I hope so. Quite far down there. Maybe you couldn't see all that. So I'll just review it. So I've made this one. Now I'm going to make it on here. I'll make it on here, but I'll show you first and then show you again. So we've made this shape. So we've got the two triangles there, and we've made 2 squares. And because we know that the edges, we've given them the names ourselves. And it's your triangle. You chose the triangle. It's whatever triangle you choose. That's A times B is the area of that rectangle with two triangles, and A times B is the area of that rectangle with 2 triangles. So that little bitty square there is A squared, because it's A times A there and A there. And that square there is B squared, because it's B there and B there. So the whole area of the whole big square, as we had before, is A squared plus B squared plus 2 of the rectangles made with triangles, and each of those is A times B, because it is a rectangle. So there it is. Can you see it? There it is. Yes, you can see it. A squared plus B squared plus 2 times A times B, that there and there. Right, so let's do that with our bits of paper. Let's do it, let's do it, let's do it. There we go. We've got A times B there. We've got A times B there. And then over here we've got B squared. And over here we've got A squared. And so this whole thing, let me just see where we're writing it. Okay, so this whole thing, this whole big square that we've got here is, by combining all those areas together, is A squared plus B squared plus this rectangle here, which is A times B, plus that rectangle there, which means it's 2 times A times B. And it's the same area as the other one that we made, so that area there is the same as this area here. It's the same. Look, it's this piece of paper. That's the size of it. That is the area of that piece of paper. So if it isn't quite clear, then what I would suggest is you do it again. Just go through this video again and just, I don't know about you, but what can happen to me is that I see it very clearly with the triangles, but then when it becomes a formula, then I'm like, oh, what does that mean again? And the way I managed to overcome that was to just do it lots of times, so that I can, when I see the formula, I can close my eyes and visualize what it actually means. So I can actually visualize. I can bring that over here and visualize. Let me see if you can see that. Make sure you can see that this time. There you go. You can visualize the picture. So you've got this one, which is C squared plus 4, 1, 2, 3, 4, half AB, or A squared plus B squared plus 2 times AB, but we didn't finish that one there. We didn't actually simplify that one. Hold on, let me make sure you can see what I'm seeing. We didn't simplify that one. If you take that one, that then becomes C squared plus 4 over 2 is 2AB. And this one, if we simplify this one, A squared plus B squared plus 2AB. And they are the same. The area is the same. So we can actually now say, I want to see where I can see this, where you can see this. Make sure you can see what I'm doing here. They're the same. So we can actually say, I'm going to put it, if I put it at the top, will you be able to see it? Yes. So we can say that C squared plus 2AB is equal to A squared plus B squared plus 2AB, which also means, since they've both got 2AB added to them, it also means that, make sure you can see, that C squared equals A squared plus B squared. So that's a demonstration. That is not a proof. That is not a proof. We haven't demonstrated that the angles are right angles. We haven't, it is not a mathematical proof, but it is a great demonstration. And this has been proven. And when we've spent a long time doing this, I have to say, with all the technical problems and everything. But I've gone in all the way down back to lower secondary. We've gone all the way, boom, we've jumped right in from primary to lower secondary. And now going on for years 9 and 10, what you'll be doing is you'll be looking at, I'm just going to point there, hopefully you can see it, maybe not, point it over here. There we go. For years 9 and 10, if you download the activity, you're now looking at proving that the angles are indeed 90 degrees. And then and working on, basically that's what we just jumped into. So in addition to what I've just done, you'd also be proving that the angles are 90 degrees. For primary, you're just sticking to the squares, you're just sticking to A, B, and it's all very, very clear on this document. And then for upper secondary, what we want you to do is go in and click on these links and actually do the activities on the links. Hi Marina, 10 o'clock in another, this isn't 10 o'clock, is it? I have now, just talking about doing A-level maths now. And I'm just finishing. So if you do enjoy today's one went completely wonky, technological nightmare. I was integrating a new system. Well, integrating is not the right word. I was attempting to integrate a new system, and it went, I'm just straightening out the camera, and it went all skew whiff and kerpolosh. But if you are enjoying these videos, please do go to our YouTube channel and subscribe. That's Bubbly Maths and Maths Toys. The links are in the announcements above, and if you're on YouTube, they'll be in the links below. And if you like what we're doing, please do share the lives, share the group, and share it with your friends. Let them know in what way it's helping you. That'd be fantastic. Help them, help us, help yourselves. And then at 10 o'clock, we're going to come back with an activity for early years. So if you're between the ages of 4, if you're 4 or 5 or 6, then come back at 10 o'clock and we're going to do some activities with squares and triangles. So bring your pencil and your ruler and your scissors and your paper. You can bring some cardboard, bring some newspapers, so we can have some fun with squares and triangles. Okay, so thank you for joining. Just to review, this is Caroline from Bubbly Maths, doing activities provided by AIMSEC, which is an organisation that provides professional development for teachers in Africa, in disadvantaged communities and rural communities with very little access to modern technologies. So hence using paper, newspaper, and used just as recycling as much as possible. And the resources are on a website called Aiming High. Again, the link is either in the announcements above or the description below. And if you also on the AIMSEC Facebook page, you will find daily activities and little memes to do, to little moments of inspiration. If you're stuck, if you're bored, just go in there and you can just do some little activities. So thank you for joining. See you at 10. At 8 o'clock tonight, we'll be introducing tomorrow's activities. We've got some lovely activities planned for the week. And thank you for joining. Right, I know which button to press here. Thank you. Bye-bye.